This is Fedimint Footprints, exploring what's visible. Let's dive on in. So a brief overview of what we're going to talk about. I'll do a quick intro and dox myself even more. And then we'll do an overview of Fedimint Observer, what it is, how it works. And then we'll connect to a public federation, and we'll actually pull in live data that we're seeing in the wild. And once we have that live data set, we'll take a look through that data set and look for on-chain deposits and withdrawals. And then to wrap up, we will try to construct a view of this federation's UTXOs. So again, hey everybody, I'm Brad. I've been a contributor to Fedimint since August of 2023. I focus mainly on the on-chain wallet. Also take some fun detours into things like Fedimint Observer. Prior to that, I worked at Gemini on multiple different hot wallets, including the Bitcoin hot wallet. And then previous to that, I worked at a really fun startup called SparkSwap. Pretty small startup, and unfortunately, it only lasted about a year. But it was a non-custodial Lightning exchange. You could buy Bitcoin directly into your Lightning channel. And then in a previous life, I was a degenerate working in the Chicago trading pits, making markets wearing funny-looking jackets. All right, so Fedimint Observer. You can think of Fedimint Observer as pretty much just like a block explorer, but for Fedimints. It's not quite blocks, but we'll get into that. The way it works is actually pretty simple at a high level. You connect to a federation using an invite code, and then once you're connected to this federation, you're able to query all of the public endpoints of that federation. So once you're querying these, you can do whatever you want with that data and then persist it to a Postgres database. So some of the uses thus far, what's really cool if you're a user of Fedimint, you're like, what can other people see if I'm using Fedimint? You can use this tool and just take a look at all the data that a third-party observer is able to see and then make your own conclusions. It's also proven invaluable for the dev team. We've found a few bugs, and it's really nice to be able to take a look and see which federations, if any, are impacted by these bugs, and then plan a fix accordingly. And then it also helps us identify design improvements. One of the design improvements we've identified is we don't have the best coin selection algorithm, so we will be updating that in a new version of the wallet. All right, so let's connect to a federation and get Fedimint Observer set up. So in order to do so, you could try to follow along. It's probably not worth it because you're going to have to sync a bunch of data that's going to take forever. But in a later time, you could do this. You would head over to the repo, clone it, follow the README, normal stuff that everybody here I'm sure has done before. Once you get this set up and you have your service running, you're ready to connect to a federation. So if you don't already have an invite code to a federation, you can head over to bitcoinmints.com, take a look for a federation you want to connect to, and then just copy that invite code. So Fedimint Observer is running Fedimint Observer is running a REST API server, and that's how we're going to interact with it. So we'll go ahead and just include that invite code as part of a payload. Say, hey, federation's endpoint, here's a put command. Let's connect to this federation and start following data. So if we do that, take a look at the logs, we can see we started a REST API server, we ran this curl command. It's now starting a background job for B210, which is the federation ID of the federation for the invite code that we just used. And now it starts syncing sessions. So it's going to start from the Genesis session 0, and then sync all the way up to the current session. Most of the federations we see in the wild right now have about 100,000 sessions, so it can take some time. All right, sweet. So we now have this really rich data set. We could do all kinds of fun things, but let's narrow our focus to look through this data set to find specifically on-chain deposits and on-chain withdrawals. So in order to do that, we'll do a quick overview of what a session outcome is, and then we'll take a look at transactions and what that means in the context of Fedimint. And then we'll look specifically at wallet module inputs and wallet module outputs, which correspond to deposits and withdrawals. All right, starting with session outcomes. Those of you who did not have a chance to attend Yasha's session downstairs a little bit ago, a session outcome is analogous to a block in a blockchain. But instead of having an ordered list of transactions, we instead have an ordered list of items, so a VEC of accepted items. So what's an accepted item? Pretty simple. It's just a consensus item that a peer submitted. And a peer is just one of the guardians that's running the federation. And then a consensus item is an enum with two variants. You have a transaction variant and a module variant. All right, so before we get too lost in data, let's just zoom back out real quick. We're looking for on-chain deposits and withdrawals. We now know what a session outcome is. Let's take a look at what that transaction variant is. So a transaction, this is a Fedimint transaction, not a Bitcoin transaction. And a transaction in Fedimint is very similar. It's how you send any type of value around in the system. So you have a vec of inputs, a vec of outputs, a nonce to ensure uniqueness of the transaction, and then signatures across those inputs. Great. Let's take a look at wallet module inputs specifically, which again correspond to deposits. So we'll narrow our focus on, instead of DIN input, which is a generic Rust type, we'll take a look at the concrete wallet input type. So what is a wallet input? If we peel back a few layers of this onion, we can see we have a pagan proof. All right, cool. But what is a pagan proof, and why do we need to take a look at that? Well, let's zoom out and consider how a deposit works in Fedimint. So the Federation is running a multi-sig wallet that has a descriptor. When you connect to the Federation, you're able to see this descriptor. And then if a client wants to deposit funds into the Federation, they're able to create a tweak contract key and then tweak that descriptor using this key. Once they have that descriptor, they can get this tweaked address out of it and then send that to the user. And then from any wallet they control, they're able to send funds to this tweaked address. The Fedimint client is then going to be able to observe that address for any activity. And once they observe any funds going to that address that has enough confirmations, they'll construct this pagan proof. So this pagan proof has a TX out proof. The TX out proof includes the block headers of the block that the transaction was included in, along with the Merkle proof. This transaction here is actually a Bitcoin transaction with an output index, and then the tweak contract key that was used to tweak the wallet's descriptor. Great. So we kind of have some background. We know enough to actually take a look at some data. So there's a transaction inputs table that Fedimint Observer saves information into. We'll filter specifically for wallet inputs for the federation we connected to. And then let's just take a look at the largest deposit that we've seen for this federation. And we got this chunky coin. There was a user that sent 7 Bitcoin into this federation. That's super interesting. Now there is some data that we're not showing here that's not in this table. So the pagan proof, those fields still exist. We're just not specifically saving it to this table because we don't need it there. All right, let's take a look specifically at the outputs for this transaction. So if we take this TXID and look specifically for that transaction in the transaction outputs table, we can see this. So we have 27 different notes that were issued. So we have an input that was a roughly 7 Bitcoin input. Then we have an output of 27 different outputs, all with an amount MSAT associated with it. But that's roughly all we can see there. And then just looking specifically, this is another query that just shows all of the denominations that were issued for this single deposit. So yeah, let's pause there. This took a couple minutes. I was able to spin up an instance of Fedimint Observer, connect to a federation, get publicly available data, and then I could very quickly find the largest deposit and all the notes that were issued for that deposit. Maybe keep that in mind. All right, and then as a sanity check, let's just make sure that all the inputs equal the sum of all the notes. They do. Excellent. All right, so that's deposits. Let's have a look at withdrawals. So we'll narrow our focus on this DIN input, which again is a generic Rust type. Let's make it a concrete Rust type, a wallet output. Well, what's a wallet output? We can see it's a wrapper around this payout. So a payout is a recipient, which is just a Bitcoin address, an amount, which is an amount of Bitcoin, and then the fees that will be paid by the user for this transaction. All right, similar to what we did for transaction inputs, we'll do that for transaction outputs. We'll filter specifically for wallet outputs for the federation we connected to. Let's have a look at the largest withdrawal. We have a roughly 5 Bitcoin withdrawal. So similarly, we can take the TXID, put it into the transaction inputs table, and here we have 65 different notes that the user was able to use as inputs to a Fedimint transaction and say, hey, Federation, I'd love to redeem these notes for some on-chain Bitcoin. And then again, just a quick sanity check. Let's make sure that all the inputs equal all the outputs. They do. Excellent. All right, we got our feet wet with like a little bit of exploration of the type of data we can play with. Did some simple things like look for on-chain deposits and on-chain withdrawals. But let's try something a touch more complex. Let's see if we can construct a view of this federation's UTXOs. So a UTXO is an unspent transaction output. And then this is kind of funky, but one way of thinking of UTXOs for a wallet is if you look through history and see all of the coins that were at one point spendable, and you subtract all the coins that have been spent, you're left with unspent coins. So for a federation, all of the coins that have ever been spendable are all of the deposits, then all of the outputs from change, and then all of the coins that have been spent are coins that have been used inside of a withdrawal transaction. Awesome, so we know what we're looking for. We want to see all the coins that have been used in deposits, all of the change outputs, and then anything that's been consumed in a withdrawal. Let's go back to our puzzle pieces. We kind of know what session outcomes are now. We'll again narrow our focus on consensus items. And then as a quick refresher, let's take a look at these wallet inputs. So again, a wallet input is just a wrapper around a pagan proof. And a pagan proof has a Bitcoin transaction and an output index. That's actually all we need to uniquely identify a coin. We usually call this an outpoint. So that was pretty easy. We could very quickly identify all of the deposits to the federation through time. Let's see if we can find all the change and withdrawal inputs. So as a refresher, the wallet output simply wraps the payout. A payout consists of a recipient, which is a Bitcoin address, an amount, and fees. And that is not that useful. There's nothing there that tells me what that Bitcoin transaction is or the output that actually was spent to the federation. So let's take a step back and consider how the withdrawal flow works for on-chain in Fedimint. So when a user wants to withdraw funds, they'll construct a transaction that has mint inputs, which are just ecash tokens. And then there's an output saying, hey, here's my withdrawal request. I want this much Bitcoin on chain. They will submit this to the federation, and each peer will then begin deterministically constructing a payout transaction. The payout transaction here is a PSBT, a partially signed Bitcoin transaction. Once they construct this, they'll take the TXID, add their signature, and then submit this signature to the rest of their peers as a consensus item. And then once we see a threshold of peers that have submitted this consensus item, they can then take those signatures and finalize the PSBT and then broadcast it to the network. Awesome. So instead of taking a look at the transaction variant of the consensus item unum, let's have a look at the module variant, and specifically the wallet consensus items. We have a couple other things that aren't important here, but we want to narrow our focus in on the payout signatures. And the payout signature has this TXID. We know we can observe once there's a threshold of peers that have submitted signatures for this TXID, and they will then broadcast it to the network. So we can then lean on a block explorer to query the chain for that transaction. And that's actually all we would need at that point. Because once you have that transaction from a block explorer, you can take a look at all of the inputs. We know those are coins that the wallet had that were spendable. So those are our spent coins that we've been looking for. And then we also get the change output. And the way that the transaction is constructed, we know it's always going to be the second output that is the change output. Awesome. So that's actually all we're looking for. We found all our deposits, found all of our change, and found all of our withdrawal inputs. So we can take all this, do some migrations, add some new tables, then put up a monster query like this, which actually is probably not that monster of a query if you guys are familiar with SQL, but we're not going to take the time to walk through all this. Just at a high level, we're looking at all unspent deposits, looking at all unspent change, smushing it together, and that's our view of the UTXOs for the Federation. So there's also a public instance of Fedimint Observer that's running at observer.fedimint.org. We can go there and have a look at the UTXOs of a federation. We've been using Bitcoin mints throughout this presentation, so let's have a look at Bitcoin principles. Then click on the UTXOs tab, and we can see there are 73 total coins available in this wallet as of a couple of days ago when the screenshot was taken. So if we take a look at this first coin, we can see how the output was constructed and made available to the wallet. We had a 3 of 4 multi-sig that was spending a coin. It then sent 957,000 sats. That first output is the withdrawal output. Then the second output here is the change output. And that's the coin that we just observed. So that's actually all we have. Quick tour of Fedimint Observer, and I will open it up to questions. High level or low level?
Or that one, or it's a little bit. Yeah, so you couldn't find it in the peg out proof, but you could find it in the peg out outcome. Is that correct?
Sorry, we kind of went quick over that. There is no peg out proof. You don't have to prove anything to the Federation. There is a peg out, which is a withdrawal request. So the user's constructing a Fedimint transaction where they have ecash notes as inputs, and then as an output, there's a withdrawal request. And so we can see that here. So the wallet output is wrapping this peg out, and there's nothing in there that is going to give us the information about the Bitcoin transaction or the output in that transaction. So then we have to look elsewhere in the session outcomes.
Gotcha. And it just took like thinking about like the system and how it all works to figure out what data is where, to correlate pieces of data and eventually like extract like the information you're actually looking for.
Exactly, yeah. It's really, I mean, first playing with this data set is really fun. You can start to ask it questions and see if you're able to tease that out. The dev team has some idea of what we can learn from the data set, but we still have like a lot of open questions. So yeah, you start with like, hey, do we even know what the UTXOs are of Federation? It's like a quasi audit. And then it's like, all right, does this exist inside of the session outcomes? For a long time, we're like, I don't know if it does. And then we were able to piece it together. It's not too hard once you see it in retrospect, but at the time it was sort of tricky.
That's really cool. Another related question. It seems like a ton of data, like given that every single Fedimint anything requires like every guardian to store this information. So like, what is the storage requirements for guardians in like a big federation?
Oh, for the guardians, that's an interesting question. I'm not sure how large these RocksDB, how large the Rocks databases are getting for individual peers. Yasha, you might have some idea. But I would assume on the order of like a couple gigabytes to maybe a touch higher. But then when you're actually,
I think currently with these amounts of data that we're talking about should be on the order of hundreds of megabytes. Like the size of Fedimint Observer's database, which goes into the gigabytes, comes mostly from indices and like structuring the data in a way that is easily queryable. But we don't have to do that on the Fedimint side.
gotcha, that makes sense.
That's surprisingly like lean. I would have expected it to be way bigger, just given like a single lightning payment could have like 50 ecash notes or something. So yeah, it's surprising.
Well, we put a lot of work into it.
nuts.
So I think one very important observation that we can make from the publicly available data is that if you have a lot of Bitcoin, and if there's a federation that maybe only has half a Bitcoin of total funds, don't put it all in there. You will be very visible. Like there was this one incident where someone apparently deposited 7 Bitcoin into a federation, and I think they withdrew it pretty quickly, like the next 2 days or so. And it led me to implement like a specific checkbox in Fedimint Observer to hide that day, because you couldn't see anything in the transaction volume graph otherwise, because there's just this massive spike of like in total 21 Bitcoin of transaction activity over these 2 days. And yeah, you don't get any privacy that way. Like if you want privacy, it's the same with like nearly any other system. Like don't just go in and out. That doesn't work. Like stay within like the parameters of the federation. Like if there's like half a Bitcoin in there, you can probably deposit 0.1. You will probably be sufficiently like surrounded by similar sized peers. But yeah, don't do that, what they did.
Yeah, thanks for bringing up that point. It was unclear to me if I wanted to bring up that point during the presentation, but yeah, if we looked at this data a touch differently, we just saw, okay, what block was this 7 Bitcoin deposit? What block was this 5 Bitcoin withdrawal? Like, oh, I wonder if this is the same user, and it probably is, because every other transaction is significantly smaller. So yeah, you really want to, I mean, this is a phenomenal tool to be able to take a look at, like, what threshold for this federation am I safe to deposit and then withdraw funds from? True, yes, yeah, that's, I think the total volume at the time, you bring up a great point, that it's not, you can't assume with 100% probability this is the same user, but it seems like such a distinct pattern that it would be very difficult to defend saying this was not a specific user.
I just noticed because on your first slide of the peg in, the number of nodes didn't match the number of nodes that peg out.
They're different amounts is the thing. So you could easily done something that changed the structure of the number of notes that you're holding. But yeah, it is, I think, a high probability to say this user was the same user.
Even if you can't be certain that it's the same user, it's a very high probability that these are the same funds.
Yes, yeah, that is a fair assumption.
I mean, this seems like a wide open, like kind of, a very wide, like creative landscape. Or like there's a lot that you can do to this, and it seems like we're only scratching the surface. Like, can you shed some light on some maybe ideas that you've had of different ways this data can be used productively?
Yeah, for sure. So just wanted to narrow the focus because we're getting deep into code and SQL queries. But if we expand, like, what can we do with this tool? There's some really fun ideas. So let's say that you want to normally go to status.coinbase.com. You're like, I can't interact with this thing. What the heck is going on? There is no such thing as status.fedimint.com. But what you could do is one of the publicly available endpoints, you could just query that on some type of regular cadence as a health check. Then you can see individual peers that are up and operational. Then you can track those stats over time and see, oh, this is actually a really good federation to interact with because they have a 99.999% uptime across threshold of peers. And then you can also see other federations like, there's a couple peers that have not synced a block on the Bitcoin, or have not proposed a new block from the Bitcoin blockchain since June. Maybe I don't want to interact with that federation.
Yeah, and we're actually already collecting some of the data in the Fedimint Observer backend. It's just not exposed yet. And there's some more work to be done. And maybe someone actually chooses that as a hackathon project. I think that would be awesome.
Yeah, that would be instantly valuable. And there's also, I mean, this is a fun data set. Go play with it. There's all kinds of neat things. An analogy would be like, what if you could build a block explorer for Bitcoin back in 2010? There were not too many around at the time, and a lot of people were interacting with the system making certain privacy assumptions that were completely false. But if you had a block explorer, it probably would have been quite a bit more apparent. Cool. I think that is it. Thank you guys for your attention.